In this lesson, you will learn to define and use the natural logarithm function. Now, when we talk about a natural logarithm, we first need to define what a natural exponential is. Now, a natural exponential is simply a number, and it's represented by the letter e. It's a number just like pi, where it's irrational and keeps going forever and ever and ever. And the number is approximately 2.71828. And where this number comes from is we take 1 plus 1 over n, raise that to the n power. And as n becomes extremely large, that will approximate what e would equal. And if you want to experiment, you could, and plug in some large number in for n, and you would find that the larger the number you put in, the closer it's going to get to e. So the natural exponential is just a number, which means when dealing with logarithms, we can treat the natural exponential, or the letter e, like a number, because it is a number. So a natural logarithm is a logarithm with a base of e. So it's sometimes written as log base e of x, but it's most frequently written as ln and then x. So ln means natural logarithm, and there's no base written because it is an assumed base of e. And the same rules apply just like other logarithms. So yes, it looks a little different, but everything we've learned in the last two lessons directly apply to the natural logarithm. Nothing has changed other than the base. So what I'm going to do is show you how this works with the base of e. We've learned with base 2 how to do log base 2 of x equals 5 and convert back and forth between logarithms and exponential form. Well, here we take the 2, raise it to the 5th power, that's going to equal x. Okay, so x would be 32. Here we see 2x equals 7. I can convert back the other way, where I can write this with logarithms. The base here is 2, so I write this with a base of 2. A log is an exponent, so what it's equal to will be the exponent. So it's equal to the exponent, log base 2, and the 7 goes right there. This next one, we have log base 2 of 2 to the 5th power. And remember, the exponent you can bring out in the front. So we have 5 times log base 2 of 2. And log base 2 of 2 is the same thing as 1, because 2 to the 1st power gives me 2. So I have 5 times 1, or just 5. And the shortcut, by the way, is if the base is 2, and this number is a 2, and they're both the same number, it could be 2 and 2, or 3 and 3, or whatever, your exponent will be your solution. So my answer is 5, which is your exponent. And then here we see 2 to the log base 2 of 7 power. And we know that if this base is the same as the base of the exponent, then my solution would just be the 7 right there. So that is with base 2 logs. Same thing applies with base e. So here we see the natural log of x equals 5. And remember, the base is an assumed e. So to write this in exponential form, we do the same thing we did with the base 2, where the base is e, a log is an exponent, so the 5 is your exponent. So we have e to the 5th power equals x. If you want to convert into logarithmic form, what I can do is I can go the other way, where the base here is e, so I can write this as a log with the base of e. And then a log is an exponent, so it's equal to the exponent, which is going to be the x. And the 7 goes right here. So we have log base e of 7 equals x. And remember, I can replace this log base e with a natural log. So I can say x equals the natural log of 7. Here we have natural log of e to the 5th power. And remember, once again, with a natural log, the base is an assumed e. So here we have a base of e, and this is e, and this 5 is the exponent. Well, two ways to think of this. First way is I can bring the exponent out in front, where now I have 5 times the natural log of e. And here, natural log of e, remember it's an assumed base e. If the base and this are the same, that's going to equal 1. So natural log of e is 1, so I have 5 times 1, which is going to be 5. The second way to think of this is because the base and this number are the same, my solution would just be the exponent. So either way to think of it, we get the same solution. And then lastly, here we have e raised to the natural log of 7 power. Remember, if the base here is an e, and this base here is an e, then my solution would just be the 7 right there. So notice everything is the same as with any other base 2 or base whatever. The rules all still apply with the natural logs. So here's an example where you want to simplify and figure out what is this equal to. Well, what I can do is I can get this so it's not in a fraction anymore. And to do that, I can just bring it to the numerator by making this into a negative exponent. So instead of 1 over e to the third, it becomes natural log of e to the negative third. And now because the base is the same as this number, my solution would be the exponent, which is going to be negative 3. So my solution would be negative 3. Here we're trying to write as a single logarithm. So using the laws of logarithms, but now in the context with natural logs. And here we have the 2 in the front. The first thing we want to do is we want to bring the 2 up as your exponent. So now we have the natural log of 5 squared. Well, 5 squared is 25. And then what I can do is combine by multiplying. Because I have the same base and I'm adding, I can combine by multiplying 5 squared times 3, which would give me 75. So my solution would be the natural log of 75. Here we want to solve. We have natural log of x equals 3. Well, the base is an assumed e, and to solve this, the base is e, your exponent is going to be over here, so the 3. So my solution would be e to the third power equals x, and I'm done. Here we have natural log of 1 over x equals 3. Same thing, the base is an assumed e. The 3 is your exponent, so we have e to the third power equals 1 over x. Now to solve for x, I need to get the x out of the denominator. And 2 ways to think of it. One way is think of it as cross multiplying, where I take x times e to the third, and then equals 1 times 1. And then to solve for x, I divide both sides by e to the third to get x equals 1 over e to the third. And the other way is using a shortcut, where when you see something like this, all I do is I just switch the x and the e to the third. I just swap them out. And so instead of e to the third equals, I have x equals, and instead of 1 over x, I have 1 over e to the third. Either way, we get the same solution, where x equals 1 over e to the third.